So basically, I can say, as you can see on the slide, my name is Daniel. I would like to tell you something about complex event processing, especially for the purpose of the fraud detection in the gambling domain. As you can see, the description in the brief of the talk was a little bit vague and dodgy. This is because of that. I don't know if you know the Polish regulation as Act of Games and Mutual Wagering, especially Article 29, which says that promotion of gambling in any form is illegal and may cause the may result in penalty fines or freedom restriction. So I don't know how many of you do know the confession bear, latest hit of the internet. I would like to officially make a statement that this talk is not a part of the promotion of the gambling. And I personally, I'm disgusted with any form of gambling and all. I cannot even work in the gambling industry if I could. To the point of the presentation, something egoistic. As Chet told in his key talk about me, I'm professionally working as a software architect, also a programmer in the Novomatic. Novomatic is a leading gambling systems supplier in Europe. In my day-to-day job, I'm trying to do two things. First, I'm trying to simplify complex things to make the clients satisfied. And the second is try to complicate simple stuff to challenge and improve the development of our teams. After hours, I work as a university lecturer still for a few months at AGH. And I'm a big fan of Futurama and Rick and Morty. So those two guys here, Rick Sanchez and Bender Rodriguez, are something like my emotional heroes. Okay, what was our latest activity in our development for the last year, for the last months? Basically, we were challenged to create a service that will be able to detect frauds, taking into account that the data may came from various nodes, like those may be EGMs, which may put a bet placement or cash-in operations, or some kind of error-related stuff, but also a third-party systems that makes a deposit to the central wallets. All of these informations are often stored in different data formats, but semantically means the same. It is presented here in such a form to narrow the scope of the presentation because it will be divided in three parts. First part, it will be maybe a little bit boring because it will be not so technical. It's something like a very quick introduction to the gambling domain so that you will understand why it is so hard to deploy so cutting-edge and novelty technologies. The second part will tackle the aspect of the actual use case which triggered the further development of this service I will tell you about. And the third one, hopefully we'll get time finalize it with the demo, will tackle the aspects of complex event processing pipelines, especially with the Esper complex processing engine, but also I will show some integration with the Kafka as our messaging middleware. So, chapter 1, called Legacies and Regulations Are Old Kings of the Hill. The gambling domain is very, how to say it, the gambling domain has a lot of legacies in here. Because imagine the deployment of the systems that were done 20, 25 years ago, which caused that, okay, our gaming terminals are now connected, they are functioning, there is no any fancy features that can be deployed. These terminals are working, they are bringing the money to the operator, so what you would like, why you would like to change it, why you would like to introduce some new features. And the second part is that even if we would like to do it, we cannot do it so easily because it costs. There is not only a cost of the development, of the testing, but also the cost of all of the regulatory aspects that we have to certify every software that is placed on the market, so there are no intentionally placed any mechanism that could result in cheating from the operator side. So basically we have three types of the systems. I categorize them from the context of the location of the random number generator and also the characteristic of the bet settlement. So first one is are the slots. So how many of you have played the slots in Poland or ever? Okay, we have one guy there. So I don't know if you know, but this is now it's completely legal. You can go to the shop offered by the Totalizator Sportowy and play legally, not in these strange boxes somewhere. So basically, slots are characterized in such a way that the random number generator, which decides whether you win or you have lost, is located completely on the terminal. So it just reports the information about the games to the back office for the purpose of the reporting, and finally, at the end of the day, specifying how much cash the operator have to pay in the context of the tax to the Minister of Finance. The bet settlement is almost instant. So when you press the button of the bet, then you almost instantly get the result of this gameplay and whether you win or have lost. The second type of the systems are the lotteries, when you have typically centrally deployed RNG, which is connecting all the terminals, and you have instant or delayed bet settlements. So you can either buy a ticket for the lottery and the result will be realized later, or you can buy a ticket in the lottery and get the information whether you have win or lost almost instantly. The third one, it's typical sports betting. It shouldn't have the random number generator because it's based on physical gameplay, something like betting on Wisla and Cracovia. I don't know if who are the fans of which teams. I like volleyball, so and the bet settlement is quite long. And also what I have said is completely not true, because the operators are very lucrative in what they have done. So basically they have introduced something called a virtual sports betting, when you can bet on a virtual gameplay, like a match is taking 1 minute, and the result of this match is using the RNG. So those are the types of the system that are feeding our service. Next, we have two types of markets. First types of markets are non-regulated markets. Those markets are specified by such characteristic that basically the Ministry of Finance or the regulator of a given country do not give any special regulations. You can do whatever you want if you are an operator. Requirements came directly from the operator, so basically he is the biggest stakeholder here. And the third point is that you can introduce bug fixes to your software quite fast. So basically if you fix something, you can talk to the operator and tell him, okay, I have fixed that, there are the test results, let's place it on the market. The second part of the markets are the regulated markets. Those are the markets when the Minister of Finance or the government are supervisory are supervising all the characteristics of the system. So typically, your system, when you deploy your software, have to communicate and, for example, wait for the acceptance of a given bet from the Ministry of Finance gateway. Second, they introduce some of the requirements in the context of the fraud detection. And the third aspect is that they introduce something like a licensing. If you would like to provide a system in the context of the regulated market, you have to acquire a license. So you have to go to the ministry, you have to show them your source code, they will sit with your teammates on your source code, analyze it line by line, and accepting whether these specific source files can be compiled using something called supervised build and placed on the market. And if you introduce some nasty bug, imagine what happened. There is no possibility to do something like a quick fix or deploy it somewhere to make the market or something like working again. No, you have to deal with it, and you have to wait a time that will take for the regulator to analyze your changes. Of course, there are various of possibilities to speed it up, but it's not, no, right. Okay, and going to the frauds, finally. So basically, typically when we are talking about the frauds, everyone is thinking, okay, I lost my card, someone can take that card or copy it and use it in the China or the USA. Those are the most typical frauds that are perceived by the people. In the context of the gambling, we characterize 5 types of the frauds. First one is physical cashbox tampering. This is a relatively simple one. When you buy a crowbar, you go to the gaming terminal, and you try to take the cashbox from the terminal. It's extremely hard to prevent it from the software side, as you imagine, but we will see. The second type of the frauds is called multiple coin or note caching. So when you somehow try to make the terminal accept more money from a single node or coin than it should. So typically, when you place a money in the terminal, it should be taken in, and a specified amount that you have cashed in have to be added to your balance. There are ways, probably there are ways to cheat it, and I will tell you in the next chapter how we provided the mechanism that can detect such scenarios. The third type of fraud is parallel identity usage. It means that if, for example, you are playing on the virtual lottery system, when you have a card, and this card, I don't know, it can be an NFC card, a barcode reader card that defines your identity, defines the account ID of your private wallet in the data center. If someone copies it at some point by some means and try to use it on other terminal in parallel, for example, to your gameplay, this will be a fraud. The fourth type of the frauds are the geographically dispersed locations operations, and those are the most typical frauds, as in the case of the credit cards. So someone have steal your card and done some operation in a location that you couldn't be there at this specific moment. And the fifth type of the fraud is typical cashless operations, money laundering. So you have a lot of money that is coming from illegal sources, and you would like to wash it out. So to go to the casino, play a little, and take other money with similar amount to your home. So, for example, you can then document that you have won it. And those 5 types of the frauds are our main general target when we were designing our system. But how we get there? So, chapter 2. Chapter 2 is telling about how at the end of the day we ended up that we need such a service. It all started with software that was devoted to gather the financial metrics from the gaming terminals. And as you can see on this meme, it all started with a single thing and ended up finally successfully, but we create a little bit of a monster. And this is why the next time we try to do it better. So the requirements for the purpose of this system was following. Basically, this one of the non-regulated power markets in one of the European Union countries, European Union countries. I cannot tell you which European Union country, but they are still in the European Union. Approximately 5,000 to 6,000 of the gaming terminals connected to the system, distributed across the whole country. And the business wanted us to provide a tool that will be able to gather all information about the bets, all information about the errors, and visualize the KPIs. So basically, how many money this specific slot gaming terminal have earned, or how many money this specific gaming terminal have lost in some kind of time period or correlation between the locations or something like that, or how many money a specific game on the specific, on a given set of the gaming terminals have won. This was something like 6 to 7 years ago, so this slide is not completely true, because at this time, there were no bids at all in the elk stack. So we thought something like that. OK, we need to gather some information from the terminals. We cannot touch them. They are certified, almost certified. So the operator would not allow us to modify the gaming terminal to push out the data from them, so that we can analyze it or some kind integrate. So basically, at the first step, we have written a simple script that was crawling the logs. Hopefully, in the logs, the guys from the gaming terminals have placed the information about the meters. So a meters in the gaming terminal represents all the things that can be measured there. So those meters were written in a very simple form. One-liners, approximately 200 values, which were the integers value, which represented whether there were some errors, how many games were played, and so on. And according to this definition, there is a 10 pages paper which specify what the specific integer in this format means. So basically, we have placed this data collection script on the gaming terminal. Then we have placed it in the Logstash through the Kafka, as you will see soon. Then we have processed it, placed in the Elasticsearch, and visualized it through the Kibana. But the requirements started to narrow down. So basically, we have to think about the consistent data input so that the messages will be ordered, and if they get to our back office, they cannot be lost. Then we need to somehow separate the whole processing pipelines into separate filer domains. So for example, if we got, I don't know, 3,000 messages in a given period, we cannot lose it. So if some kind of processing logic is broken at some point, then we have to restart it and reprocess once more. Of course, we needed the synchronous message processing and also the authentication and authorization stuff here. And we have incrementally came to something like that. So basically, we have utilized Kafka as our messaging middleware as a simple write-ahead log. When we place a message on the Kafka, despite whether it's from the terminals itself or some kind of the supported systems which were necessary to also gather this information, we can process it in accordance to the logic we can modify in the backend. So we had a set of the Logstash instances that simulated something like stream processing. Imagine how hard it was to create something that is not appropriate for the final solution. But basically, we were successful. We have achieved something like that. We were able to provide the business operation with near real-time data from the gaming terminals. And these dashboards, which we have provided for them, were more or less quite easily configurable. So if they wanted to correlate some information that, for example, the producer of the terminal is playing better or not, they could do it here. At the end of the day, it showed up that even the simple Lucene query language or Elastic query language is not so easy to use by the business people, even when they were semi-technical. So all of this stuff had to be done by our guys, and we have done it. Of course, there were a lot of problems with the data because we have handled the data that was sourced from different terminals. Sometimes there were data inconsistencies which we received, but we fixed it. And the last part of this story is that we are a few months working on the production. We have fixed all the critical and blockers that prevented us from the proper operation. And basically, we achieved a great success because the business have told, OK, we have increased our revenue by 5 to 10% because we are then able to modify the content on the terminals. So basically, they use the tool to gather information, what type of content can be placed on the terminal to be more attractive. And then we get a mail, the mail that was saying, hey guys, it seems that the bug that we have 2 releases ago is alive once more. So you screwed up, fix it as soon as possible. At the beginning, no. Software engineers, we create code, so we create bugs, as you can see from the keynote. So we started to analyze. We started to analyze everything we have. First, we started from the Logstash processing logic. It was really hard because the team was not so big. The legacy there was quite big, so we had to do something like real-time analysis in the production environment. But we have checked that, OK, Logstash is working correctly. There are no problems. The pipelines are good. OK, so maybe we have screwed something up in the Elastic. No. The Elastic is also good. The indexes are proper. Everything is fine. OK, so obviously we have screwed up the dashboard so that they are not showing the data in a form that they should. Finally, it's shown up. No, this is also good. So the only point that we didn't check was the gaming terminal. It's like, OK, so we have a problem with the incoming data. So we checked the logic. No, it's fine. It's working as expected. We didn't even change it in the last 2 releases. So we had to find the source of these inconsistencies. At the end of the day, so something like a spoiler alert, we implemented a very nasty and custom mechanism that allowed to identify 2 types of the frauds. The one of them was multiple caching operations, and the second was money laundering detection. So how we done it? This is this big and ugly stuff that shouldn't be created, but it worked at the end of the day. So first, we created, for the purpose of the multiple caching operations, placing the money into the terminal and taking the note out of it so that the terminal accepts it and you still have the money in your hand. And you do it a few times. It worked. Supposedly, it worked. So we implemented a custom Python script that crawled to the Elastic and checked whether there are subsequent events that represents the caching on a specific partitioned by terminal ID in a given time period. This is, I can show you this script after the presentation. How does it look like? It's nothing that should be presented there. It's bad, but it worked at the end of the day. And the second stuff was money laundering detection. So this one was a little bit tricky. It required from us to identify a pattern when the player came to the terminal, put the notes, play 2 gameplays with a really low stake, and they take the money out. So basically, if you have something like an illegally earned money and you would like to change it to a legal money, you could do it, if someone do not have such mechanism. So this one was implemented as a Logstash plugin that created something like a session of the player for when there was a first caching operation on the gaming terminal. The Logstash persisted this event as a session for a given terminal and then tracked how many gameplays were done in a given time period, and when the session ended, when someone placed cash out on the terminal, then triggered an alert. So we have implemented that. We have placed it on the market. And after, I think, 2 months, the guys from the business have written to the team a quite nice email like, hey, guys, your mechanisms are working. We have caught the criminals. Now it's better. So that is something like a personal success. Yeah, we have done something that helped the world better, like helped the operator earn more. So that was good. But then we started to think, OK, but this is not the way we should do it. First of all, we have spent a lot of time to do it, and it's hard. So here is how we came to chapter 3. So complex event processing pipelines using Kafka Streams and Esper. This one is really good. So this was something like we have felt, like our software have told to us, make me better, make me not look like that. What we decided to use. So basically, you remember this slide from the beginning of the presentation. So basically, the concept inside is extremely simple, because I personally, I'm a very big fan of, lately, making things simpler, because if they are complex, they are complex to explain to the client, they are complex to explain to the software team, the development team, and after 2 months, they're complex to understand even for me. So if those things are not simple, then we have done something seriously wrong. So basically, using the similar technology stack, we started to migrate to other, more appropriate approach to detect the frauds. Kafka is well known by everyone. Who know Esper? One guy. Unfortunately, my colleague from the PhD, so hello, Marek. OK, so you will see what it is. Who know Kafka and Kafka Streams? Yeah. So Kafka Streams are those are not good stuff. I would not like to do something like introduction to KSQL and Kafka Streams there, because if you want to do it from the last year, Devoxx Poland 2018, there's a great talk of Tim Bergland, processing streaming data with KSQL. Watch it. It will be much more better than I present. So this is the guy from the Confluent.io. So they are making everything better in the context of the Kafka. But basically, to introduce and to get the more or less the same set of the knowledge, Kafka is a typical write-ahead log, nothing more. Kafka Streams are the tools that allows you to write statements, SQL-like statements, that are able to process incoming data and put them in a different form on another Kafka topic. And you can do it in a streaming way, so you can subscribe for a constant update of those events. So using the Kafka Streams, you can basically write your own event-driven architecture and modern systems, and then you will see that you don't know what's happening inside, because there are a lot of topics and the data is flowing and you are not monitoring it, but you can try. So we tried a little bit different approach, but very similar to Kafka Streams. So to use the dedicated engine devoted for the complex event processing, only for the complex event processing. And the complexity here is not about the complex structure of the events or the complexity of using it. It's about the complexity of correlating and reasoning what can be done. So this is about the complex event processing, that we are trying to correlate events flowing from multiple streams and detect patterns. Basically, at the end of the day, it's all about windowing, grouping, and pattern detection. Nothing more. There is no magic there. If you only are quite comprehend and understand how to define those patterns, then you specify them in a dedicated DSL, and you are done. And of course, everyone have to be SQL-like compliant, so nevertheless, Esper is also here. This is the high-level architecture from the Esper engine, like stream processing engine. It's a big project, open source. You can take the Esper tech. Unfortunately, it's GPL. Fortunately, no, I'm a fan of open source and of free software also, so GPL is also cool. But basically, you specify statements that represent your logic of processing the streams, and you get an update. If you make those statements complex, they will be complex. So going through the processing model of this complex event processing, the easiest and the most hello world-like statements are select everything from stream called withdrawal. So if you only send an event to that stream, then you will get, as a consumer of that stream, every update on every new event received, with all the data associated. This is quite easy. Then you can aggregate the stuff. So basically, you don't need to write a code to do some aggregation, sums, or some mathematical fancy operation. You have a lot of existing operators. OK, counting maybe is not so big, but sum also. OK, but you can compute the coefficients or something like that. But basically, if you write something like that, the internal of the engine is doing the aggregation for you. So registering such a statement will give you following results. If you get an event with an amount of 500 of something, you will get an update that you got one event and the sum is 500. If you get a second event with 100, you will get an update, OK, we have two events in the stream, and the sum is 600. And this will follow. But not limiting this cause that you will get something like a very simple computational logic that is not so fancy there. So you can, of course, filter all the stuff using the properties that are passed in these events. The properties are either JSON fields, either fields of the plain old Java objects, or any other binary message that is supported here. So basically, you can write your statement and filter through some kind of the properties. The behavior will be quite understandable. It gets more complicated, so you can filter and aggregate. So apply the filter and aggregate only those that came out from this filtering information. But the most funny and most interesting part starts when you are talking about windowing or pattern recognition. So the windowing is nothing more like specifying, OK, I'm interested in sliding windows, for example, which means that I would like to have those aggregations or those sums only for the last n events. In the sample here, you will see that this event length is 5. So basically, at the time of the working of the system, if you get a new information, you will get information about only the last 5 events. There is a bug in the documentation of Esper. You will get information about all the events here. So you are not forsaken, like you have to store it somewhere. It will give you. And the other type of the events are the time-based windows. So basically, you can specify, I would like to get all the events which were caught by, for example, the last n seconds. And this, the processing model, will look something like that. If we get more events there, we will get the updates. This is still also quite understandable. There is nothing more. But the funny part begins here. So in the context of fraud detection, it's all about patterns. Patterns of events that came from the external systems or user activity. So if you have only the features, the capabilities to specify those patterns, then you can try to define the policies that will represent your fraud detection logic. So here, this particular solution allows you to define the patterns using following meta language. You can order the sequentiality of the events using this, how it is in English, arrow, right arrow. So here the left predicate is followed by the right predicate. You can also correlate the events that are subsequential, that are defined in this statement, and for example, do something like joins. This is similar to the joins in the SQL. So here, I would like to get a notification every time when the event X is before the event from the event stream, event Y, and the correlation ID of my second event is the same as the correlation ID of my first event. So here is a typical example how to try to join two types of events from two different streams. And the example actually from the single event stream is the following. So I would like to get notification when there are two cash out operations, one after the other, both with the amount of cash higher than 400 pounds, and the second event arrived at least 10 minutes after the first one. So if someone here will be making a cash out, this is not fraud detection rule, but to make it something like more concrete, if someone is making a cash out with a value bigger than 400 pounds, so then the engine starts to create something like a context. If we get another cash out after that one within a time window of 10 minutes, we will get a notification. And more informative stuff is to also partition by something. Of course, in the stream processing principle, you are not creating a stream per entity. So for example, if you have 5,000 of users, we would not divide our architecture into 5,000 of streams, because then if we get a new user, we would have to create a new stream. So basically, you are creating something like a user activity stream. We have a field user ID, and then from these streams, we are trying to process it. So this statement is used to do exactly something like that, to create an inner partitions in our stream, where here we specify by which the partition have to be made. And this one of the actual statements that we are using is looking like that. So from the created context called segmented by machine ID, which partition all the events by machine ID, so we have internally a collection of the event stream partitioned by each of the machines, we are trying to find the pattern like that. Okay, so those are the examples, and now I would like to show you how the real case pattern recognition statements looks in our system. So it looks something like that. I will address 3 of them to show you more or less what are the capabilities, and then I will show you the fancy simulator that I have written yesterday, to demo something that will prove that that is true. So basically, we are talking about the physical cashbox tampering. Actually, I have told previously that we are limited there. We cannot identify something that someone is trying to destroy the terminal with the crowbar. Actually, we are. In every gaming terminal, we have something called sensor. So there is a sensor for the doors, there is a sensor for the cash boxes, or something like that. Typically, the business have told us that if someone is trying to break the terminal using the crowbar, those sensors are flickering. So we get information on off, on off, on off. So this statement is something like a heuristic and tell, okay, if I get 3 subsequent pairs of event that represents the flickering of the sensor, so this is a coloration of the sensor from the stream, then give me an alert. So basically, if we will have within 3 seconds repeatance of these 2 pairs of this pair of the events, fraud alert will be generated. Next, we have the multiple coin and node caching fraud detection mechanism. Similarly, we are partitioning by machine ID from our caching event stream. Then we are creating a pattern that will match every caching event that is followed by the caching event with the same amount, and that is finally followed by the third event with the same caching amount. This is not our work. The guys from the operation have told us, typically guys are trying to do it 3 times. And so they're trying to do it twice, and then the third time they leave the banknote inside so that no one is suspicious. But we have to detect whether, for example, because we have to limit it. So this is a contrary argument that check whether between those 3 events of subsequent cachings with the same amounts, we did not receive a bad placement event. So basically, this will trigger a fraud alert only if we have a situation that someone is trying to do a caching event, followed by caching event, followed by caching event, and in between of them, there is no bad placement event. As I said, this is a heuristic, so it will not work. Now you can go to one of the European markets and try to cheat. And the third one, showing a little bit another point of view, it's parallel identity usage. So basically, we're trying from our bet placement event stream, partition all of the information about betting in a given account ID, and check whether there is information that 2 subsequent bet placement events happened for the same account ID from different location. So this is a simplified form of this, because location typically in our case is a big fat JSON which describes a lot of stuff. And if it happened with 1 minute, 5, 10 minutes, the rule here should be much more intelligent, then an alert will be generated. To not do something like only talking and talking and talking, which I like, I would like to demo it and hope it will work. It should. OK. So here is, OK, you see nothing. So wait a moment. I will just increase the font. OK, font to 34. OK, it can be. So basically, here I started typical single node Kafka broker. It will be needed for a further part of the demo, and I need to start the idea. OK, the code will be old and nasty because I have done it yesterday, and yesterday was Father Day, something like that in English, so I didn't have too much time, but it should work. So let's see. OK, so maybe I will change to the same display as the one display. Give me a moment. This will be easier for me. OK. Now you should see the same as me, not this slide. OK, one moment. Increase font size. OK. So basically, this is a typical Spring Boot application generated with Spring Initializer. What I have done here is, as my entry point, I created a bin called Esper test runtime initializer, which is doing nothing more that is initializing. OK. OK. Wait a moment. Press. Oh. Okay. I like it. I love it. Alt tilde. No. Color scheme. Oh, yeah. Default. Okay. Sorry for that. So basically, I will leave the presentation mode also. Okay. Yeah. More? Now it's good? Okay, so basically what I'm doing here, I'm initializing the configuration. The configuration of this specific engine is... Wait a moment, I have a mouse, it's faster. I have turned on the scrolling, zoom. I had a mouse. Yeah, I had a mouse. So no, we have to live with it. I have to live with it. So as here, you can see that I'm registering the schema of the streams. And here my streams are nothing more like plain old Java objects, so a typical POJOS that contains a few of the properties. Then, using this provided using this provided runtime, I'm initializing it, and I'm registering a set of the statements as were shown in the demo session. So basically, they will get a notification about all the updates here. And the last part is that I have written a very fancy user input simulator that in case of receiving a number 1, 2, 3, it's sending the cache-in event with an amount 1, 2, 3. In case of sending pressing button 6 to 7, it's doing the bet placement, and in case of pressing the 0, it's generating the sensor flickering. So basically, if I do something like that, you should see here that sending cache-in event, and the event was sent. One of our statements was telling that if we have 3 subsequent events of the same type, we will get an information notification about that. So here is what we get. We get an information that, okay, a pattern have been matched. All the events that were here are shown, and some Kafka stuff I will tell it in 2 minutes. So basically, if I do something like cache-in win 1, 2, 1, 2, I will not get a fraud or something like that. On the other hand, we had a statement that was telling whether there are 2 bet placements from different locations, we should generate a fraud alert. So the 6 is generating a bet placement from the Krakow, somewhere from here, and the 7 is generating a bet placement from the Warsaw. This is a very simple simulator to show that these patterns are working. And the last thing is that we can generate a flickering of the sensors. And if you analyze the content of these events, it will only generate if I do it 3 times in a period of 3 seconds. So here we got an information what events generated this data. But as I have said at the beginning, putting every information into the complex event processing engine is not what we want to achieve. We wanted to achieve that if we get a frauds, we want to something like a control loop and to place the information somewhere back, for example, in Kafka. So I could write either my nasty code to handle the Kafka client, or I could use the predefined configuration for something called Kafka output adapter for this engine, and all the patterns that are tagged that they should be outputted to the Kafka will be done. So basically, if you see once more, there is an information that the caching pattern has been matched, and the proper event was sent to the Kafka, because in our code, we have specified that this specific multiple caching patterns should be outputted to the Kafka. All of the stuff with configuration, it's not the magic stuff. It's also here. It's just presented in something like that. So we have those fraud alerts here. And if I didn't screw up, and I think if I will do something like that, OK. Wait a moment. Split to the right. So this is our cluster of Kafka. And here we should have OK. Docker compose exec Kafka bin. If I remember correctly, we should compose, we should exec into the container in the that hosts the Kafka, so that we will get the command line tools responsible for that, but we will see. Yeah, but this is Docker Compose. It has a slightly different, we are here, so we are going to the Kafka instance, and I will show you that those messages are getting there. And OK, we have this bin. And here we have, it's called Kafka console consumer --boot server localhost 1992 --topic route alerts. OK, I was. OK, and one more thing I didn't show from the beginning. So I will once more use our fancy simulator to generate a fraud. And voila, it's here. So basically, of course, it's nasty and it's very raw. So typically, we should define a separate stream called machine caching events, frauds, and then maybe enrich them with some other information, when this happened, who have done it, and so on. But more or less, it shows how it should be done. And going back to the presentation, that was my last slide. I am out of time. So thanks for being here, and I would appreciate your question if there are any. Yes?
What are the scale limits?
Once more?
The scale limits.
Of this engine. OK, so there are 2 points here. This engine is open source. It's available under GPL. The company that is trying to provide the bandwidth is telling bandwidth information and performance test is telling that it's very efficient, because all of their statements are compiled into the bytecode. So it is not processed using something like a pattern on regexp stuff, but represented as something like an abstract syntax tree of the objects that represents those statements that we register here. So I was, without the problem, I was able to process something like a few hundred events per second on my laptop with doing more complex stuff. But the main problem is that there is something like a HA and highly scalable setup of this, also using the Kafka, but it is paid. But it's quite easy to do it on your own. If, for example, you can partition the streams on the Kafka and place to the underlying engines something like a sharding, only the information that is necessary for specific cases, it should be easy. But it is told to be very efficient. Yep. So the Okay, so the question is whether I have done any we have done the comparison in AWS stream processor. Short answer, no. But in general, there is a few solutions that can be used here. Something similar, but a little bit different is Drules. Red Hat Drules, you know, the guys here. This is a reasoning engine, so it is capable of doing the same stuff. You can do it, but with a little bit different approach. The point is that this solution that I have told you, it's quite long, quite old. So it's not a new player on the market. It's here from the 2006, I think. So when I have heard that Kafka Streams was announced in 2016, I have smiled and told, okay, now you have to be more mature to get to the level that you will be able to represent this pattern recognition. Okay? Sorry? Yes. So exactly as you have asked, we are planning to put the first part of the processing to Kafka Streams, basically to normalize the data, to make sure that all of the streams coming from multiple tenants that can fit our system are represented in the same form. And here, in these blocks, do only the processing that can be expressed in such a form, because you can also write off all of this logic, processing logic from Java code. But it's not the way we would like to go. We would like to have it clear, because what's important, we have to show the regulator that this piece of software is doing exactly that. And these semi-technical guys understand the SQL. So we will be a little bit easier there. No? Okay, so if there is no question, thanks one more, and feel free to ask me whenever you want in the context of complex event processing for frauds. Thank you.